Hello students, so hope you all are good and safe, and let's start with our today's session. And before starting our today's session, let me give some highlights of our previous lectures. So previously we just started one new topic based on the logarithmic of complex variable, in which we did little bits notes of that particular method, and then after we solved three examples, right? And now hope you all practice these all the sums, and now we are moving forward with the same procedure, with the same method only. So with part 1, and you can see that here it's given a fourth example based on the logarithmic functions. So let's start our today's session, guys. In this session we will do some more examples regarding the logarithmic functions. So let's start, guys. And here it's given, prove that I raised to I is real and find the value of log sin log I raised to I. Okay. Okay, so in these examples, first of all, you have to prove that I raised to I is a real number. It means after finding the value of I raised to I, it must be in a condition of real, with only a real number. There will be not included any kind of function I, yani ki complex number. It must be in the form of real number only. And secondly, you have to find the value of sin log I raised to I. So from these two functions you can start with any part. So first of all I am starting with the part, I am giving you pointer. So I'm first of all I am starting with the part sin log I raised to I. Okay, now you can see here sin just keeping as it is and log I raised to I. Now you know that how we can solve log I raised to I. So I'm just applying I outside, so that I mean we are just using a logarithmic rule. So we can split like I log I. I'm giving some highlights. See this one. The simplification of this one by using logarithmic rule we can apply in this way. I log I. Suppose it is given log 3 raised to 2, then we can apply 2 log 3. Again repeating, guys, if here it is given log 3 raised to 2, yani ki we can apply 2 log 3. So same way we are applying for the I raised to I form. Okay. Now sign as it is and I will be also as it is, and you know the value of log y, that how we can solve. Just a minute, guys, I'm giving some highlights of this. Okay, you have to solve this one, the value of log I, and you know that how we can solve log I. So as we have discussed in our previous session, that normally mostly we will use the formula of principal logarithmic only, right? So same I'm applying here also. So just I'm keeping I as it is, and here you have to compare I with the x plus iy. I'm writing here, guys, if anybody don't know, then x plus iy. Okay, so comparing it with x plus iy, the x will be 0 and the I will be 1. So I've written here log of under root 0 plus 1, yani ki under root x square plus y square, yani ki 0 plus 1 plus I tan inverse y upon x, and y yani ki 1, so 1 upon 0. So after giving the simplification you will get this one answer, that -1. I hope, guys, you can do this simplification of this all the examples, because I'm not going to do this. So then to, if anybody have any kind of queries, then you can contact me anytime, guys. Okay, now next we are going to find first one part. that it's given to prove I raised to I is real. Okay, so we are having a function I raised to I, so I'm just applying one important thing, that first of all you have to apply log on both the sides. Whenever the function will be in the form of raised to form, then always in the very first step you have to apply log on both the sides. Okay, so so that here it will be I log I, and again in place of log I, I'm just highlighting, see guys, log I you can apply its formula, and also here we have applied. So from that you can directly write. So this one is being minus pi by 2, but actually you just need the value of I raised to I, so just making a subject of I raised to I, so that it will be e raised to minus pi by 2, yani ki this one. And as you can observe, in this answer we are not getting any kind of I, so we can say that this answer is coming in the real form. So that's why the sign of log I raised to I will be minus 1. Here it's given its final answer. Okay, so hope everybody understood guys. Now next one is again very much easier, and it is same like the fourth one example. Prove that, but here it's given only a single part, right? So the question is given, prove that cos of log I raised to I equals to 0. Okay, so first in the very first step you will simplify this term, yani ki I log I, and then after you will apply the formula, yani ki principal value for the log I, yani ki this one. Okay, as we have applied here also, you can see that हम लोगों ने इधर भी apply किया है guys. Okay, so with the same formula you will apply here. After, the cos of log I raised to I will be cos I pi by 2, and cos pi by 2, you know the value of this will be 0. So this one is very easiest example. Now sixth one, you can see that, show that cos of I z bar equals to z bar yani ki z conjugate equals to given cos of I z yani ki the whole bar of cos of I z. Okay, it means either you can go through LHS to RHS, or else you can go through the RHS to LHS form. But here I am doing with the LHS to RHS. Choice is yours guys, which one will be easiest, you can go with that procedure. Okay, so right now I'm going through the LHS to RHS. So you can observe that here it's given cos I z bar. Okay, and there is one formula of cos iz yani cos hz. This I yani ki circular function, h is given yani ki hyperbolic function. There is a formula regarding this, and this one we will do in our next method. Okay, so right now guys you just accept this formula, because these all the formulas we are going to do in our next sessions. So till that just accept it guys. Okay, and first of all what we did, we have converted this circular function into the hyperbolic function. Okay, and now hyperbolic to I am applying real function. I'm doing highlight also. See, from circular to we applied into hyperbolic, and from the hyperbolic we have applied into the real function. Okay, and this formula you know very well guys, right? Because this one you already studied in first and the second semester, hyperbolic for the sine and hyperbolic for the cos functions. Okay, then also I am repeating guys, in first or second semester we have applied cos hx in place of z bar. Z बार की जगह पे हम लोगों ने वहां पे अप्लाई किया था गाइस x, राइट, बट यहाँ पे z बार है. सो जहाँ पे x आ रहा था यहाँ पे वहां पे हम लोग क्या लिखेंगे अब, z बार. सो द formulas of cos hx is being e raised to x plus e raised to minus x upon 2, right? So for this function, here it will be cos h z bar, यानी कि e raised to z bar in place of e raised to x, here it will be e raised to z bar. So e raised to z bar plus e raised to minus z bar upon the 2, and this one having a separate conjugate, it means we can apply this whole function conjugate, and this one is again one rule of the conjugate function. Okay, and now this one is, you know very well that this one is your hyperbolic function. So again I have applied into the cos form, yani ki the bar of cos h z, and so that we can apply hyperbolic to circular function, yani ki in place of h you will write I. So this one is again a formula of hyperbolic to circular. Here we have applied circular to hyperbolic, and at the last again we will apply hyperbolic to circular function. And again repeating guys, this formula we will study in our next sessions. So till that just accept this formula. Now next one, you can see the question is given, show that sine the whole bar of sine of iz equals to sine of iz bar if and only if z bar equals to n pi I. Okay, so here you have to prove, you have to show some functions, and that is in the power, in the component of n pi I. So based on this formula you can think that here n is coming in the answer, and for this answer of course you have to use that general formula, right? So here we will use the general formula of the logarithmic functions. So first of all I am just applying this components functions, that whatever it is given into the equation. Okay, then after we will apply the circular function, and this formula again we will do in our next sessions guys. So right now just you have to accept this formula, that in place of the bar of sine iz equals to, we can write I bar of I into the sine h z, and here also sine iz equals to, we can write I sine h z. This one is very much important formulas, and our coming next sessions I will give this all the formulas, then it will be very much easiest for you. Okay guys, now next sin hz की formulas that you know very well now, that this one will be e raised to z minus e raised to minus z upon 2, and actual this one is being e raised to x minus e raised to minus 6 upon 2, but here it is given z, so it will be e raised to z minus e raised to minus z upon 2. Okay, and again this is formula, because you can see that here it's given a conjugate yani ki bar, so it will be minus I, right? Yani ki this one is coming from there, and here I as it is the hyperbolic of this, yani ki e raised to z bar minus e raised to minus z bar upon 2. Okay, now next I will be cancel out from this both sides, yani ki this one and this one. Okay, so the remaining term and also these two and these two will be just a second guys, I'm doing with the another marker so that you can see that. Yani ki these two as well as these two will be cancelled, so the remaining term will be minus of e raised to z bar minus e raised to minus z bar equals to e raised to z bar minus e raised to minus z bar. Now just rearranging the term and you can get this final value, yani ki this one. Okay, now putting these whole terms in a single side, so I'm shifting this term, I'm shifting this term in the left hand side, so that you can get e raised to 2z bar equals to 1 यानी कि this one. Okay, now I'm removing exponential so that it will be 2z bar equals to log 1, and you know the simplification of log 1 yani ki by using the general formula, because as we have discussed here in the answer it is coming n form, and to bring n form we have to apply its general formula. So I'm just I have applied here, and you can see the last simplification. You are getting these numbers what you are going to find, that is z bar equals to n pi I upon n pi I, where n belongs to z. So I hope you all understood, guys, and in this session we did 4 more examples regarding the logarithmic functions, and still there are some sums are remaining, but that all we will do in our next sessions, and some of the sums I will give you for the practice. So till that, guys, please do this all the sums of the logarithmic functions. Till that, do your work safely and properly. Thank you, guys. See ya in our next session.